Welcome to The Explainer. Today, we're diving into something pretty wild, a new way for AI to create images. It's a breakthrough, really, that teaches an AI to paint a picture using the exact same logic it uses to write a sentence. I mean, you've seen them, right? We're all seeing these stunning AI images every single day. You've got photorealistic portraits that look so real you'd swear they're photos, and then these epic fantasy landscapes that feel like they're straight out of a movie. AI art is, well, it's everywhere. And it's totally reshaping what we even think of as creativity.
But have you ever stopped to think about how the AI actually does it? Like, what's going on under the hood? Well, it turns out there are two very different ways these AIs think to create an image. And getting a handle on that difference, that's the key to understanding the huge leap forward we're going to talk about today.
Okay, so think of it like this. On one side, you've got the sculptor. This is the diffusion method. You've probably heard of models like stable diffusion. They start with just a canvas of random static, pure noise, and then they kind of chisel away at it, refining the whole thing all at once until a clear picture emerges. It's like finding a statue inside a block of marble. But then you've got the writer. This is a totally different method called autoregression. It builds the image piece by piece, patch by patch, predicting what little bit should come next, kind of like how a language model predicts the next word in a sentence. We're going to be focusing on this writer approach today because it's been stuck on a really big puzzle for a while. All right, so let's get into it. What exactly is this puzzle that's been holding the writer models back? See, the whole idea behind building an image sequentially, patch by patch, is, well, it's really elegant. It works exactly the same way a large language model writes text. And that's a huge deal. It could be the key to a unified AI that handles all sorts of data, words, pictures, you name it, in the same way. But there's always a but, right? There's been a major catch. So here's the problem. To make this whole process work, the models had to simplify the image first. They used this technique called vector quantitation, VQ for short. The best way to think about it is like a paint-by-numbers kit, It takes all the amazing, complex details of a real-world photo and squishes them down into a very limited visual dictionary, like you only get 8 colors in your paint set. It forces everything into these preset boxes.
And as you can probably guess, that simplification came at a huge cost. Fine details? Gone. Rich textures? All fuzzy. There was just this persistent, annoying quality gap when you compared them to the sculptor models. So here's the bottom line. These autoregressive models were stuck. They had to make a choice. They could be fast and efficient with a small, simple paint-by-numbers kit, or they could aim for high quality with a massive, slow, clunky one. They just couldn't have both. Well, until now. And this is where it gets exciting. A team of researchers at NextStep-1 have built a new model called NextStep-1. And what it does is find this incredibly clever way to just shatter that trade-off. So how in the world did they do it? Well, NextStep-1 basically takes that whole paint-by-numbers kit and just throws it in the trash. The key innovation here is something they call continuous tokens. Instead of cramming image data into a limited dictionary, it treats it like a continuous spectrum of information. Imagine going from a kid's watercolor set to giving a master painter a full infinite palette where they can mix any color imaginable. That's the leap we're talking about. Okay, so here's the new process. First, you feed the model your text prompt, along with any bits of the image it's already made. Then, this super powerful transformer, it looks at all that and predicts the complex hidden information needed for the very next patch of the image. And then, and this is the cool part, a small, lightweight piece called a flow matching head jumps in. Think of it like a precision painter's brush. It takes the transformer's prediction and generates that next high-fidelity patch, turning the big idea into actual pixels on the screen. And when I say powerful transformer, I mean it. The engine driving this whole thing is a beast, a 14 billion parameter transformer. So the brain of the operation, the part that's doing the understanding and predicting, is absolutely massive. It has this incredibly deep grasp of language, concepts, and how they link up with what we see. All right, so you've got this new architecture, but how do you actually train a model to think like this? Well, you start by feeding it a really diverse diet. In its first training stage, this model crunched through over 1 trillion tokens of data. Most of that, 60%, was high-quality image and text pairs. But to give it a well-rounded education, it also studied text-only books and articles, and even things like video frames to get a better feel for how things flow in a sequence. And the training was smart. It was this progressive 3-stage curriculum, kind of like going from elementary school to college. In stage 1, it just built the basics, understanding image structure at a low resolution.
In stage 2, it learned to be flexible, handling all sorts of different image shapes and sizes. And then for the final exam, a stage called annealing, it was trained on a small handpicked dataset of only the most beautiful images to really sharpen its artistic eye and boost that final aesthetic quality. Okay, so the theory is cool, the training sounds intense, but the real question is, how good is it? How does this new writer actually compare to the top sculptor models out there? Well, the results are pretty fascinating. Let's look at the numbers. On tests that check how well the AI follows a really complex prompt, putting the right objects in the right places, NextStep-1 is the new champ. It doesn't just beat the other writer models, it actually edges out one of the top sculptor models, Stable Diffusion 3.5. That's a huge win. And it's not just about putting things in the right spot. What about general knowledge? When you ask it to generate images that require some real-world smarts, like concepts from biology or physics or culture, it again comes out on top. This thing doesn't just paint. It seems to have a real understanding of the world. And here's where that unified writer approach really shines. It makes the model incredibly versatile. It's not just for making images out of thin air. It's a master at complex editing based on your instructions. You can tell it, hey, add a cat, but you can also say, change that wooden chair to a glass chair, or take the style of this Van Gogh painting and apply it to my photo. It's pretty amazing. Okay, so let's step back for a second. What's the big takeaway here? What does a model like NextStep-1 really mean for the future of all this? Well, this brings us to what might be the model's biggest secret, something the researchers discovered. They found that the size of the part that does the painting, that little flow-matching head, it barely affected the final quality at all. And what that strongly suggests is that the huge 14 billion parameter transformer is doing all the real work. It's doing the heavy lifting, the creative thinking, while a tiny, efficient little module just handles the final painting. Mind-blowing, right? Now look, it's not perfect. The team is very upfront about the challenges that are still left. For one, generating an image patch by patch is just slower than doing it all at once. And working with this super rich continuous data can sometimes lead to weird visual artifacts or noise. And of course, scaling this up to create gigantic, super high resolution images is still a really tough nut to crack. But here's the thing. Those are engineering problems. They can be solved. The conceptual breakthrough, that's already happened. By proving that an AI can write a picture with the same fluency it uses for language, NextStep-1 has finally closed that quality gap. It's opened the door to a whole new way of thinking about generative AI, and it leaves us with a really big question. If an AI can now write a picture just as easily as it writes a sentence, what happens next when that line between painting and writing completely blurs away?